Have you ever heard people say that the more HDL particles that you have, the better your health outcomes are going to be when it comes to your lipid markers? Now, HDL is a particle that is essentially going to be synthesized within our intestines and our liver. It starts off as a very, very small protein, and it will go round to the tissues and essentially take up any excess cholesterol that has been deposited in places that it shouldn't be, essentially. And I'll explain more about this in a moment. But the HDL is also important for actually donating certain protein components to our other LDL particles. Now, the other LDL particles that I'm talking about that I'm sure you've heard of are chylomicrons, VLDL, IDL, and our LDL, which is the most commonly known and spoken about LDL particle. So the protein components that the HDL is going to donate to the other LDL particles are the following. It's going to donate something called an ApoE, which is kind of like a recognition particle that will sit on the membrane of the lipid molecule, and it will allow target tissues to be able to recognize it and say, hey, I need some of that, I'll take that in. Another protein component that the HDL will donate to these other molecules is an ApoC2. The ApoC2 is really important because it's a protein that is going to be recognized by target tissue like fat cells, muscle cells, liver cells, and it's going to stimulate special enzymes called lipoprotein lipases. And their job is to actually snip up components within the LDL particle and take it into that target tissue. They can then do what they want with it. They can use it to make energy, for example, in the muscle cell, or they can store it for whenever we need energy in the future, like for example, in our adipose or our fat tissue. But HDL doesn't stop there. So you might have heard of your LDL cholesterol. Now, LDL is the smallest particle when it comes to our lipids in our blood. Now, the reason this is relevant is because this particle is so small and contains so much cholesterol that it's often implicated in diseases like atherosclerosis. Essentially, this particle can end up depositing into our vessel walls. They can then be engulfed by our macrophages, which are a type of white blood cell, and form something called a foam cell. And this can, of course, obstruct blood flow through that vessel. But what's so amazing about the HDL is once it's synthesized within our intestines and our liver, it starts off as this tiny little ApoA1. And this little particle will then go to places like the foam cells, and it can actually bind onto these foam cells and slurp up any excess cholesterol that they might be containing. But it doesn't stop there either. It can then take that cholesterol that it's slurped up and go to other tissues that really, really, really need cholesterol. Like what? Well, our adrenal glands and our gonads. They actually use cholesterol to actually make very special hormones like our sex hormones and our stress hormones, our blood pressure regulating hormones. And so it's important that these tissues do receive the cholesterol. So isn't it amazing that the HDL can not only take cholesterol from places that it shouldn't be, but it can then take that cholesterol and put it into places where it should be?